Okay, so we've got a few exam questions from past papers here. I'm not going to instruct you each time I do one of these, but I would recommend that you pause each one before I go through the answer. Attempt it yourself, do as much of it as you can, and then watch my solution so you can compare how you did. Also, if you get stuck on a particular part of it, if you get stuck on a particular part of the question, watch my solution until I do that part and then pause again. Some of these are a lot harder than others, and I've just kind of mixed them all together. So if if you find one that's not appropriate for what you're wanting to work on now, just skip forward until we work on the next one. Okay, so anyway, let's get on with this then. So here we've got a curve, just sort of. So this one doesn't really use any second year calculus, so hopefully this is relatively straightforward. So this equals 2x minus 2, and then x, 24 root x, we need to rewrite as 24x to the half. So that becomes 12x to the minus a half. And then for part B, for part II of part A, the second derivative, 2, the 2 disappears, the minus 12 becomes plus 6, x to the minus 3 over 2. Verify that there is a stationary point when x equals 4. This word verify, it's important to be sensitive to the language that's used in the question. When it says verify, we just have to check that there is a stationary point when x equals 4. So now, obviously, if it said prove, we could prove it in the same way, but the word verify just kind of indicates that you're not going to have to actually make dy by dx equal to 0, solve that for x. We could just plug in x equals 4. So dy by dx when x equals 4 is 2 times 4 minus 2 minus 12 times 4 to the minus a half. That's 8 minus 2. 4 to the minus a half is 1 over 4 to the half, so that's 1 over 2. So 12 times 1 over 2 is 6, and that equals 0. So that verifies it. Determine the nature of the stationary point, giving a reason for your answer. So if we sub in x equals 4 to the second derivative, we get 2 plus 6 times 4 to the minus 3 over 2, which equals 2 plus, okay, so 4, square root of 4 cubed is 8, so that becomes 6 over 8, which is positive. So we're dealing with a minimum. Okay, so a nice little warm-up question. It doesn't actually use any of the second year calculus, but obviously the exam the exam you do in the second year has first year content on it too. Okay, so I'm going to zoom in a little bit with that. Let's put it over here so I've got room to work on it. Okay, so this one is a trig function and it's a quotient. So we're going to be using the quotient rule. So it'll be u dash v minus uv dash all over v squared. So dy by d theta. So u is the function on the top, v is the function on the bottom. So u dash is 3 cos theta. V is 2 sine theta plus 2 cos theta minus u 3 sine theta times v dash. So we need to differentiate 2 sine theta, which becomes 2 cos theta minus 2 sine theta. So that's v dash all over v squared, which is 2 sine theta plus 2 cos theta squared. We could see from the answer that what we need to do here is simplify all this and get a load of stuff to cancel out. So let's, and it looks like we need to multiply out the denominator. Usually with quotient rule questions, you resist expanding that bracket on the bottom. It usually simplifies more easily if you leave it factorized. But I think here it looks like we need to expand it. Oh, just the sine 2 theta, if you've not covered double angle formulas yet, let me give you the formula for sine 2 theta. So if you've not covered the trig for the second year with double angle formulae, don't worry, you can do this question, but you will need that that identity. So let's just go ahead and expand the top here. Might need a bit more room. I'll put my equal sign over to the left there. So we get 6 cos theta sine theta plus 6 cos squared theta minus 6 cos theta sine theta plus 6 sine squared theta. Hopefully you can see that a lot of that simplifies. And then multiply out the bottom, we get 4 sine squared. I'm going to put the 4 cos squared next to it so it's more obvious how we simplify that. Plus 8 sine theta cos theta. Okay, so on the top there, we've got a 6 cos theta sine theta, which cancels with the minus 6 cos theta sine theta. And then we're just left with 6 cos squared theta plus 6 sine squared theta. So I'll pull out the 6 as a common factor. And then on the bottom, we've got 4 cos squared plus sine squared plus 8 sine theta cos theta. So using the identity cos squared theta plus sine squared theta equals 1, we get 6 over 4 plus 4 sine 2 theta. Divide everything by 2, we get 3 over 2 plus 2 sine 2 theta, which is 3 over 2 bracket 1 plus sine 2 theta. Now that normally would be fine for our answer, but if we look, we actually need to get 1 plus sine 2 theta on the bottom. So it looks like we made a mistake, but actually, if we look at the phrasing of the question, we can see a needs to be a rational constant. So it doesn't have to be a whole number. So we can take that 2 up to the top of the fraction. Obviously, normally you wouldn't do that because fractions generally have integer numerators, but that's the form that we were asked to get it into. And so parametric equations, again, if you've not covered parametric equations, don't worry, we just need to use this formula, dy by dx equals dy by, and it's t in this case is the parameter, so dy by dt by dx by dt. Might want to put brackets around them because it's like, you know, I don't know, you might just prefer it to look like that. Right, so we've got the point C as those coordinates. Find the value of dy by dx at the point P. So dy by dx equals dy by dt. So over here we've got y. So it's a sine, so it's sine 2t, so it'll become 2 times cos 2t. So that will be 10 root 3 cos 2t, and that's over dx by dt. When we differentiate tan, we get sec squared. So this will become 4 sec squared t. Again, if you've not covered that part of trigonometry, don't worry. It's just that is what you get. So at the point where t equals, where let's say x equals 4 root 3, that means that 4 root 3 equals 4 tan t. So tan t equals root 3. So t equals pi over 3. So dy by dx at that point where t equals pi over 3 is 10 root 3 cos 2 pi over 3 over, I'm going to write, because our calculators don't have a sec button, so I'm just going to rewrite this as 4 times 1 over cos squared pi over 3. And 2 pi over 3 is 120, so I'm just using my calculators on my phone here. So cos 120 is root 3 over 2. So that is minus 5 root 3. And cos of pi over 3 is a half. So this is 4 times 1 over a half squared, which is a quarter. So this becomes minus 5 root 3 over 16. Okay, so now the point Q lies on the point. I'll do B here. Point Q lies on the point where dy by dx equals 0. Find where Q is. Okay, so dy by dx equals 0. Where is dy by dx? It's up there. That means that the numerator equals 0, so we don't have to worry about the denominator. 10 root 3 cos 2t equals 0. So cos 2t equals 0. So 2t equals pi over 2. And if we look, t is between 0 and pi over 2. So 2t is going to be between 0 and pi. So if we were to find other values, that the other solutions in this range, there aren't any. You know, if we do 2 pi minus that value, we get the other roots, and they're not in the range that we want. So t is pi over 4. But we want the coordinates, so we need to find x and y. So x equals 4 tan pi over 4. And y equals 5 root 3 sine of 2 pi over 4, or pi over 2. So that gives us the coordinates. Tan of pi over 4 is 1, so that's 4. And sine of pi over 2 is 1, so 5 root 3. Okay. Okay, Find dy by dx, write your answer as a single fraction. So what they're sort of instructing you to do there is to use the quotient rule. If you treated this as a product, you get two terms, which they're not wanting you to do that. They want you to use the quotient rule. So if you do use the product rule for some reason, you're going to then have to add your two terms together to make them into a single fraction. So we're going to use the quotient rule. So it'll be u dash v minus uv dash all over v squared. So dy by dx. U is the top of the fraction, v is the bottom. So we get u dash, which is 4 times v minus u v dash all over v squared. Simplify that, we get 4x squared plus 20 minus 8x squared. And that becomes 20 minus 4x squared. Which is 4 bracket 5 minus x squared sort of looks like it should cancel, but we've got 5 minus x squared, not x squared plus 5. Part B, find the values for which dy by dx is less than 0. So that denominator is never less than 0. So we're just interested in where the numerator is less than 0. So that's x squared is greater than 5, which means x is greater than root 5, or x is less than minus root 5. Are any of those values not allowed? No. Show that dy by dx. Okay, so they've given us the answer here. So this one we need to differentiate implicitly. So we get 2x. And now we've got to be a little careful here because the 2xy, there's a minus sign in front of it. So when we use the product rule, we've got to make sure that we get the right signs. So I'm just going to avoid any ambiguity and make sure I'm okay. I'm going to leave the minus there and then just do the product rule in brackets and then deal with the negatives afterwards. It's quite common that people put the first term negative and then the second term positive. So 2xy, so u dash for that is 2, v is y, and we add uv dash, so that'll be 2x dy by dx, and that's in brackets, so both terms need to be negative when we get rid of the brackets. 3y squared becomes 6y dy by dx, and the 50 just goes to 0. And okay, so let's get all the dy by dx's together there. We've got dy by dx, and we've got 6y minus 2x. Get the other terms on the other side. So there's a minus 2y, so it'll become plus 2y when we add it to the other side, minus 2x. So dy by dx is 2y minus 2x over 6y minus 2x, which simplifies to y minus x over 3y minus x, as required. The curves used to model the shape of a cycle track. P and Q are the furthest west and furthest east. Using part A, find the exact coordinates of point P. Now, for this, we need to know what is going on at these points. Yeah. So at Q, we've got a vertical gradient. Vertical gradient. So you can think of that as being an infinite gradient, which makes sense, doesn't it? Because if we had a really steep curve that wasn't quite vertical, it would be very, very big, and we could make that gradient larger and larger and larger, arbitrarily large. So you can think of it as being infinite. So when dy by dx is a fraction like this, in order to get a vertical gradient, we need that denominator to be 0. Yeah, because that's where it's undefined. That's where we get sort of infinite gradient. So if it's a vertical line, the denominator is 0. If it was a horizontal line and we're dealing with a stationary point, the numerator would be 0 because dy by dx equals 0. So at the vertical gradient, 3y minus x equals 0. We need to find the point P. So we found 3y minus x equals 0. So that's like y equals a third. So what we've shown there is that those points P and Q, if I can draw this line correctly, those points P and Q, they lie on the line 3y minus x equals 0. So we haven't actually found the point by plugging that value in. The same happens when you try to do a turning point as well with implicit differentiation. You get a curve, well, a straight line as your answer instead of a value. So now we need to solve simultaneously. So let's rearrange this. So we get x equals 3y. We'll sub that value into the equation of the curve. So the equation of the curve is x squared, so that's 3y squared, minus 2x y plus 3y squared equals 50. And that gives us 9y squared minus 6y squared plus 3y squared equals 50. So 9 minus 6 plus 3 is 6. Y squared equals 50 over 6, which is 25 over 3. So y equals plus or minus the square root of 25 over 3, so 5 over root 3. And x equals 3y. So the two coordinates then, for plus 5 over root 3, we get 3 times 5 over root 3. 5 over root 3. And the other point will be minus 15 over root 3. Minus 5 over root 3. You could write that in third form. The question said give the exact coordinates, which doesn't necessarily mean it needs to be written in third form, but it kind of does look a bit better, but that's fine. Explain briefly how to find the coordinates of the point that's furthest north of the origin. I already alluded to that, so I won't bother writing it down, but I'll explain. If we wanted the point furthest north, that's actually a turning point. So we'd do exactly the same thing as we did for the points P and Q. I've just realized I gave both coordinates, but it was only asking for point P. P has a negative x value, so P is that one. Good job I looked back at the question there. that's our final answer. Now, if we were trying to find that point, vertical, most northerly point, that's a turning point. So we do exactly the same thing as we did in part B, except when we were looking at this dy by dx expression, we would make the numerator equal to 0, not the denominator. Okay, and we would get y minus x equals 0. Okay, so that's all you have to write down, just because it's not actually asking you to do the calculation. It just wants to ask you how finding a horizontal line is different to finding a vertical line. So we get, when we do this algebraic juggling, we want a factor on the top, which is the same as the denominator. Now, we want to fill in this next bracket so that we get, when it multiplies out, we get most of the terms on the left there. So in order to get an x to the 4, when we multiply this out, we need an x squared. Now, this bracket is now quadratic, so we need to think about the number in front of x. So when we expand these brackets, we want to get x cubed. Now, where do we get x cubed terms? We get 1x cubed here, and we get the other x cubed term there. Now, because we've got 1x cubed, when we multiply those together, and we want to have 1x cubed, we don't want any more x cubes, so we need so there is actually a 0 in front of x. There's no x term. Now, for the number at the end, we need to look at the x squared term. So we want to have minus 3x squared. And where do we have an x squared? Well, we get an x squared when we do x times this, so that doesn't give us anything. We also get an x squared term here, so we get minus 6x squared plus whatever this is, and we want that to be minus 3x squared. So minus 6x squared plus 3x squared is what we need. So that needs to be plus 3. And now we just need to tidy up, because we've got those first 3 terms when we expand these brackets, but the others don't match, because we need a 7x. Now, if we look at this, where do we get an x terms? X, we have 3 times this x, and this no x's times that 6. They're the only places we get an x term. So we've got plus 3x, but we want plus 7x. So we have to add another 4x. Now the number, we only have one term, one multiplication where we get a number. So it's minus 6 times 3 is minus 18, but we want minus 6. So we've got to add 12. So that mess there is equal to the numerator on the left. And the reason we've done that is because we can split this into 2 fractions, both of them over that denominator. And what happens there is the denominator cancels on that first fraction. So we're left with x squared plus 3. That second fraction, we're going to be able to simplify it further, because this denominator factorizes. So the x plus 3 cancels. So we're left with x squared plus 3 plus 4 over x minus 2. Hence or otherwise, find an equation of the normal at x equals 3. So B, we want dy by dx. Okay, so we need, for this equation of the normal, we need dy by dx, which will be 2x, and then remembering that 4x minus 2 to the minus 1, so this becomes minus 4 x minus 2 to the minus 2. We want that value when x is 3. So dy by dx at the point where x equals 3 is 6 minus 4 times 1 to the minus 2, which is 2. And we also need the y coordinate when x is 3. So when x equals 3, okay, let's sub it into the simplified version we've got. F of x equals 3 squared plus 3 plus 4 over 3 minus 1. So that's 9 plus 3 plus 4, which is 16. So the equation of the normal then is y minus y1, which is 16, equals m. So the gradient we got up here was for the tangent. We want the normal. So it's minus a half times x minus 3. So that's 2y minus 32 equals minus x plus 3. Does it say how it wants it written? Find an equation. So let's say 2y plus x equals 35. That's an equation of the normal there. Part I. Let's find the turning point. So this is a product rule, so it's uv. So we're going to use u dash v plus uv dash. And we get dy by dx. U dash is 3e to the 3x v, so cos 4x, plus u e to the 3x. V dash is minus 4 sine 4x. There's a common factor of e to the 3x. And we want it to equal 0. So dy by dx equals 0. That means this thing that we found equals 0. E to the 3x cannot equal 0. So it must be the trig part that equals 0. So we need to think a little bit about how we solve this. Now, because it equals 0, we can just use tan. If the right-hand side was not 0, we would have to use the r cos theta plus alpha type approach. But because the right-hand side is 0, we can divide everything by cos 4 theta to give us 3 minus 4 tan 4 theta for x. So tan 4x equals 3/4. It wants the answer to 4 decimal places. So yeah, my calculator's in degrees mode. We need to be in radians. Divide that by 4. Is that in the range we want? Between pi over 4 and pi over 2? Yeah, so what is pi over 4? 0.7. So that actually is not the answer that we want. So if we go back to this equation, we actually need more. We need the other solution. So for tan, we add 180 to that. So 0.6435 plus 180 plus pi is 3.7509. So when we divide that by 4, we get 0.9463. And that's in the range of values. Okay. Let's move that answer back in here so that I can work over here. Part 2. Another function, and we want dy by dx as a function of y. So again, because it's written as with x as the subject, we can use the trick we used on the previous question and find dx by dy, differentiate with respect to y. You could also just differentiate with respect to x implicitly. Both approaches will work. We are actually doing that essentially, you know. But let's just differentiate with respect to y. So sine 2y. So remember that is when we're doing differentiation, we need to think of sine squared as being sine of 2y squared, and it's we're going to use the chain rule because it's a bracket squared. So we get 2 times that bracket multiplied by the derivative of the bracket, which is 2 cos 2y. Now we don't write a dy by dx because we are differentiating with respect to y. So let's simplify that a little bit. We get 4 cos 2y sine 2y. That is of the form 2 sine theta cos theta. So we can rewrite that as 2 sine 4y. So dy by dx is 1 over 2 sine 4y, which is a half cosec 4y. For this one, we've got y equals a product there. So because it's the product rule, we're going to be using u dash v plus u v dash. And we're going to call u, x, and v 2x plus 1 to the 4. So dy by dx equals u dash v. So u dash is 1, so that will just be v. And then x for the u, and then v dash. So v dash is a chain rule, so we'll do 4 times the bracket cubed, and then multiply by the 2 that's in the bracket, so that will become 8 times 2x plus 1 cubed. Now, notice when we did the product rule, I think the past paper question I did, it just said differentiate. So you would get full marks for what we've written so far. But when they want you to simplify the answer, they phrase it like this. They've given you the answer or the structure of the answer, and you've got to show that you end up with that. So essentially, it's instructing you to factorize. So with this one, we've got a common factor of 2x plus 1 cubed. We want to take the lowest power as our common factor. Now, if we take out 2x plus 1 cubed from the first term there, we're just left with 2x plus 1. And then if we take out 2x plus 1 cubed from that second term, we're left with 8x. That just needs tidying up a little bit. Okay, and let's just double check that is in the form that the question asked. It should be 2x plus 1 to a power times ax plus b, so that's great. So this is parametric equations, and I think when I did the video on parametric equations, I did say that if you've not covered parametric equations yet, you can still do this. It's a simple formula. You just differentiate the y, differentiate the x, and then divide the y by the x. So you can do this if you want. So part A, sorry, I just got dust on my iPad. So part A, I'll just remind you of the formula. Dy by dx equals dy by dt over dx by dt. So that will be, if we differentiate that y term, we get minus 2 sine 2t. So it becomes minus 2 root 3 sine 2t. And we differentiate the x, we just get minus 2 sine t. And that will do. I am going to simplify because it looks like we're going to be using this later on in the question, so it's easier to work with if we've got the simplified version. Okay. And part B, I'm going to squeeze part B next to it so we can kind of keep the question on the screen there. Part B, the point P lies on C where t is 2 pi over 3, the line is normal, and show that an equation for L. So because this is a straight line, we're going to be using y minus y1 equals m times x minus x1. Now, we need y1, x1, and m. They haven't given us any of those terms. So to find x1 and y1, we use the fact that t equals 2 pi over 3 and sub them in to the definitions. So x1 equals 2 cos 2 pi over 3. So let's just, so 2 pi over 3 is 360 over 3, which is 120. Cos of 120 degrees, I think, is it minus? Let's just work it. Let's just see what it is. Cos of 120 is minus 0.5. Oh, and it's 2 times that, so we get minus 1. For y1, we're going to do root 3 cos 2t. So that'll be cos 4 pi over 3. And let's just work that one out. 720 over 3. That's minus 0.5 as well. So we get minus root 3 over 2. Bonus points if you could do that one without a calculator. I didn't manage it. Okay, so that's my x1 and y1. So now to find m, we sub our t value into dy by dx. So we get root 3 sine 2t, so that will be sine 4 pi over 3 over sine t. Okay, and sine of 4 pi over 3. I'm using my phone calculator, so it does have a radians mode, but anyway, so 4 pi over 3 is 240, so that gives us minus root 3 over 2. So that'll be minus 3 over 2 when we multiply it by root 3. And sine of 120 is just √3/2. So that becomes -3/√3, which is minus √3. So our gradient is the normal, so m will equal the negative reciprocal of that, so it'll be 1/√3. Just leave it in that form. So now to find the equation of the normal, it's going to be y minus y1, which is up here, minus √3/2, equals m, which is 1/√3, x minus x1, and x1 is -1, so it'll be x plus 1. Let's just multiply both sides by √3 first. We get √3y plus 3/2 equals x plus 1. Multiply everything by 2, we get 2√3y plus 3 minus 2x minus 2 equals 0. So 2√3y minus 2x minus 1 plus 1, sorry, equals 0. Now, is that the answer they gave? Minus 2√3? Oh yeah, okay. They've put the x first. So right, okay, so technically we've not got the answer they said, but we can just say that equals 2x minus 2√3y minus 1. Okay, what's the next part? The line intersects the curve again at the point Q. Okay. And the curve is that. Okay, I'm going to go down to a new page. And I'm going to grab, I'm going to grab the two equations that I need. I need that one. And I need that one. Let's just check the question. The line intersects the curve again at the point Q. Find the coordinates of Q. You must show how you found your answer. Yeah, because you could cheat with a graphical calculator there, couldn't you? Okay, so that's asking us to solve simultaneous equations. Now it's worth 6 marks, so it's a bit blurry, unfortunately. It's like a photocopy of a photocopy, isn't it? Okay, so we've got to solve this to find where it meets again. I think if you've not covered parametric equations, you can quite comfortably skip this part because this is not really about differentiation anymore. This is firmly in the parametric equations section. So if we solve this, we just substitute so that we've got everything in terms of one variable. So we've got an expression for x there, we've got an expression for y there, so we can sub them in. So substitution, if we say call that equations 1 and that equation 2, we'll substitute 1 into 2, and we get 2x, so that's 2 times 2 cos t minus 2√3y, so it's √3 cos 2t, minus 1 equals 0. So now we've got an equation, and it's got a cos t and a cos 2t in there. So we're going to have to use some trig identities to solve this. Let's just simplify it a little bit. So we get 4 cos t minus 2 times √3 times √3, which is 6 cos 2t minus 1 equals 0. This uses year 1 trig, so we should, oh no, it doesn't, sorry, the double angle formula is year 2. So you need to have some familiarity with the double angle formulae. So I'll just sketch over in the corner. Cos 2t is cos squared t minus sine squared t. So if you've not covered double angle formulae, that's the identity we're going to be using. We just want it to have cos squareds in there, so we can actually substitute sine squared t for 1 minus cos squared t, and we get 2 cos squared t minus 1. Okay, so rearranging that. Oh no, we don't need to rearrange that. So we substitute that in here. We get 4 cos t minus 6 times 2 cos squared t minus 1 minus 1. And let's simplify that, make it a quadratic. We will get 12 cos squared minus 4 cos. And we get 6 minus 1 is 5, but move it over, it'll be minus 5. Okay. So this is the quadratic that we're solving. Does it factorize? 60. And I think it might. Yeah, 60, 10, and 6. Okay, so ten and 6, so it'll be minus 10 plus 6. Okay, and just check that works. And if we multiply that out, we get minus 5, minus 10 cos t plus 6 cos t. Okay, so that works. So that tells us cos t equals 5/6 or minus a half. Sorry, all the way back up to the question. We want the exact coordinates of Q. And Q is the one where t is not 2 pi over 3. So it was, cos was minus a half, wasn't it? Yeah, so the 2 pi over 3 is this one. So we're not interested in that one now. So we're interested in cos t equals 5/6. Yeah, okay, so if cos t is 5/6, we're wanting the coordinates. So x equals 2 cos t, which is just 5/3, and y equals, okay, so for y equals √3 cos 2t. Again, because it's wanting the exact value, we can't work out cos 2t from cos t because our calculator just gives us a decimal here, but we can use this identity. Now, I'm using my phone as a calculator, so it might actually be that your calculator gives an exact value for these, but I don't think it does. So we're going to have to use the identity for cos 2t here because we've got a value for cos t. So that becomes √3 times 2 cos squared t. So that's 2 times 5/3. No, 5/6, sorry, squared minus 1, which, oh, sorry, work from before. So this gives us 2 times 25 over 36. So it's root 3 times, so we've got 50 over 36 minus 1. So that'll be 14 over 36, which is 7 over 18. So this becomes 7 over 18 root 3. Is that correct? Yeah. Okay, so our coordinates are 5/3 and 7/18 root 3. Okay. Okay, next question. We've got a quotient rule here, so we are looking at u dash v minus uv dash all over v squared. So dy by dx equals u dash will be 10x plus 10. Multiply that by v minus u v dash. So u is 5x squared plus 10x. V dash will be 2 bracket x plus 1 to the 1 all over v squared, so that's x plus 1 to the 4. And there is a common factor here. There's a common factor of x plus 1, so we can cancel that with one of these. And so then we'll get 10x plus 10 x plus 1 minus 5x squared plus 10x times 2 all over x plus 1 cubed. Then let's get on with simplifying that numerator. So this becomes, expanding all this, we get a 10x squared plus 10x plus 10x plus 10 minus 10x squared minus 20x squared. All those terms on the top cancel out, so we are left with 10 on the top. All the x squareds cancel. That 10x squared cancels with that 10. These 10s cancel with 20. Sorry, that's not 20x squared, that's 20x. And we're just left with 10. Hence, deduce the values of x for which dy by dx is less than 0. So for part B, dy by dx is less than 0 when x plus 1 cubed is less than 0. Okay, now normally you would have to solve an inequality to get that answer, but if you look at the question, it's only worth 1 mark, which indicates that it should be pretty obvious what's going on there. Now, with a fraction that has 10 on the top, the only way that fraction can be negative is if the denominator is less than 0. Okay, next question. Okay, so let's see how we can go with this. So we are looking at, now I don't like this question because deduce the value of k. It's asking you to work out what k is, given that the domain is all positive x values except k. Now that's their definition of the function. So it seems a bit weird that we have to figure out what k is, but obviously by a process of elimination, the only thing that k can be is the value of x that makes this function invalid. Now, this is often a trick with functions that's helpful, is looking where the denominator equals 0. So if log x minus 2 is 0, so g of x undefined when log x minus 2 equals 0. i.e. when log x equals 2. So that means x equals e squared. Log base e. If log base e of x is 2, that means e to the 2 equals x. I always do a little, with log equations, I always do a little dance across the equals sign. Base e to the 2 equals x. Okay. So x equals e squared. So that's the value that makes it invalid. So k must equal e squared. B. Let's grab the definition. Just bring it down here. It's got even fuzzier. So what we're trying to show, we just want to prove that g dash of x is positive for all values of x. So first we need to find g dash of x. So this is a quotient, so we're going to use u dash v minus uv dash all over v squared. So g dash of x. Okay, so u dash is going to be 3 over x, because when we differentiate log x, we get 1 over x. The minus 7 disappears. Times that by v, so times that by log x minus 2. Take away u, v dash, so that will be 1 over x, all over v squared. Okay. So we can take that common factor of x onto the bottom of this fraction, and then the top becomes log x minus. Sorry, we've got. I'll multiply it out. 3 log x minus 6 minus 3 log x plus 7. So that becomes 1 over x log x minus 2 squared. So that's our expression for g dash of x, but we need to show that g dash of x is positive. Well, this must be positive. Since x is greater than 0, by definition, if we look at the original equation, x is limited to being positive. And log x minus 2 squared, that's positive. It can't equal 0 because the value of x that makes that equal 0 is not allowed in the domain. So if x is greater than 0 and log x minus 2 squared is greater than 0, the whole thing must always be greater than 0. Find the range of values of a for which g of a is greater than 0. Okay, let's get another page added on here. And let's drag our definition of g onto this next page. Okay, so for this to be greater than 0, the numerator needs to be greater than 0. Okay. Okay, next question. We've got another quotient rule. So we're going to use u dash v minus u v dash over v squared. So u dash is just 1. V is 2 plus root x minus u v dash, which is half x to the minus a half all over v squared. So this, let's expand the top. We get 2 plus root x. And now we've got to multiply this right hand bracket out. So we've got x to the minus a half there times x. So we get minus a half root x. X times x to the minus a half is root x. Plus 4 times a half. Oops. Times x to the minus a half. So that top, let's multiply the top and bottom by 2 root x to simplify that numerator. So if I multiply the top by 2 root x, we get 4 root x plus 2x minus x plus 4. Now we've multiplied the top by 2 root x, so we need to multiply the bottom by 2 root x. Simplify the top, we get 2x minus x is just x. Plus 4 root x plus 4. Now that numerator is 2 plus root x all squared. If you expand 2 plus root x squared, you get you get 4 plus 4 root x plus x. So this is 2 plus root x squared and we get the cancellation, so we get 1 over 2 root x. Okay.